Our lesson for today will be looking at chemistry. The topic is chemical equilibrium. This is lesson 103. Let us start. The lecture goal for today's lesson will be looking at how to write Kc expression. We will be talking about Kc expression on the next lesson video where we have to calculate it. Now in this lesson video we are just going to be looking at expressions, how to write the expression of Kc. Now the general expression is Kc is equals to the concentration of the product over the concentration of the reactants. Now you should take note that only gassed and aqueous phased substances will take part in this equation. Substances which are solid phased and liquid phased, they don't take part in this equation. Now in order for you to understand how we use this equation, let us look at a number of examples. The first one, suppose we have nitrogen reacting with hydrogen to form ammonia. And then balancing this equation, we're going to have 3 here and we're going to have 2 here. So what is the Kc expression for this equation? By the way, this is also gas phased. So we say Kc is equals to the concentration of the product divided by the concentration of the reactants. So we are going to have Kc is equals to, now we look at our product, it's ammonia. So we are going to put the concentration of ammonia. And then this coefficient will be our power. So we are going to put this coefficient here, power 2. All divided by the concentration of nitrogen. Since nitrogen doesn't have any coefficient, the concentration of nitrogen. Since nitrogen doesn't have any coefficient, it means we're simply going to put 1 here. Multiplied by the concentration of hydrogen. And you should take note that it's multiply. You don't add but multiplication. Then the coefficient is 3, so we're going to put 3 here. So this is the Kc expression for this particular equation. Let us look at Kc expression for this one. So it's Kc, it's equals to, now we can see that on the product we have calcium monoxide and carbon dioxide. But looking at the phases, we can see that this is solid phased, this is gas phased. So remember that we only consider the gas and the aqueous. So only this will take part on the side of the product. So the concentration of carbon dioxide, since that it doesn't have any coefficient, it's simply going to be 1 over the concentration of the reactants, but we can see that we only have solid phased substance, so it will be over 1, so it will be CO2. So this is the expression for this particular equation. Let us look at another example. Looking at this, we can see that these are the reactants and then we have our product here. So we have Kc is equals to the product. Since we can see that the product is liquid phased, so it won't take part on the Kc. And then looking at the reactants, we can see that we have 2 substances, but one of them is liquid phased, so it doesn't take part also. Only this one will take part. So in this case, we can see that we only have Cl2 on the product side to the power 6. But since on the the product side, we have this, and it's the only substance but in liquid phase, then we're going to put 1 here. So this will be our Kc expression for this particular chemical reaction. For the next 5 examples, just make sure that you pause the video, you work out the Kc expression, you play the video and verify your answer. The first one, pause the video, work out and play the video and verify the answer. So it will be Kc, it's equals to The product, we can see that they're in gas phase, so it means that this chemical reaction, we can see it's a homogeneous chemical reaction. So we're going to have concentration of CH4, there's no coefficient, multiplied by concentration of H2S, then we can see the coefficient here, so we're going to put 2 here, all divided by concentration of CS2, concentration of H2 to the power 4. I hope you got this one correct. Let us move to the next one. Let us look at this one. Remember, pause the video, work out and play the video to verify. So we have Kc, it's equals to the product, as you can see that it's in liquid phase, so we cannot write anything. Instead we're going to put 1 over, then we can see that the first substance that will take place is this hydrogen, so H2 squared multiplied by CO. Even if you can write it this way, it's still fine. I hope you got this one correct. Our next example. So we have Kc is equals to, we can see that this is solid, so we cannot write anything. So we're going to put 1 here, divide by. This is also solid, we cannot include it also, so we are left with this one, which is CO2. I hope you got this one correct also. This is our next example. So we are going to have Kc is equals to NO2 squared all over O2 multiplied by NO squared. Our last example, so it will be Kc is equals to, now we can see that this is in liquid, so we cannot include it in our expression. So we're simply going to put 1 here, divide by, let us actually do this, CO H2 squared. So basically this is how we write the Kc expression. Now the next lesson video will be looking at calculation of Kc. Actually, it's very important to go through this lesson video so that in the next lesson video, when we generate this equation, you will know how we generated this equation. The next lesson video will be looking at calculations when you are given the equation and data. Then the question will say calculate the Kc expression, the question would require you to calculate the Kc for that particular chemical reaction. So just make sure you go through this lesson video again before you go to the next and understand. Now we are done with our lecture goal. This is Bahula SJ. Thank you very much.